All right, so understanding powers of I. So what I mean by this is, let's say you, let's say that you're asked a question. Let me see if I have it. So like I to the 27th power, or maybe um, I to the negative 100 and 12th power. What is that equal to? Understanding powers of I. So let's talk about how you can better understand powers of I. There's an easy way. There's oftentimes in life you have an easy way and you have a hard way. So I'm going to tell you what I think the easy way is. Now first, you can't escape this one. I, you got to know that I is the square root of -1. That's, you got to understand that. But that's really, if you can work out with some logic, right, then you can get the rest of it. This is what goes against logic right here, but everything else is logical. So now let's think about, well, I squared. I squared, well, that's just the first thing squared, right? If you square one side, you square the other. So square root of -1 squared, that becomes -1, right? So that's all we're going to do. Sometimes you watch, even in my past videos, I went to the 4th power and showed how it's a pattern. And that is the case, but I don't want to get into that because I think this is the easier way. All right, so let's look at our first example and say I to the 27th. Now, a couple things that we need to first understand is, maybe I should erase this. You got to understand some things about exponents and about multiplying exponents. So first, I guess if I say I to the 27th, then I can say that's just equal to I to the 26th times I, right? So this is a principle of multiplying exponents, which says if you have a to the x power times a to the y power, then it's equal to a to the x times, or x plus y, right? So that's something you need to know. If you don't know that already, a lot of people already know that, so that's cool. And then let's take this a little bit further, right? Now 26. Well, if I use what I know about the I, right? If I use what I know about I can say I squared. 26 is an even number, so I can express that as I squared to some power, in this case the 13th power, times I. And let me show you how that works in case you're like, oh, this is getting to be magical, right? So let's come down here real quick. Another property of exponents is, I'm going to just use a number. If I say 2 squared to the 3rd, right? 2 squared to the 3rd, that means I'm saying 2 squared times 2 squared times 2 squared, 2 squared, right? 2 squared 3 times, which then if I pair that with my multiplication property and I say 2 squared times 2 squared times 2 squared, I can say that's 2 to the 6th, right? So then I can say stuff like 2 to the 6th is equal to 2 squared to the 3rd. Does that make sense? Hopefully so, because I can't hear you. Nah. All right. But that's called the power property of exponents. So we can use that, the addition property of exponents, or the multiplication property of exponents with the power property, and we can use that to simplify i's, powers of I. So watch this, right? So I squared to the 13th times I. So hopefully you can see how I to the 27th is equal to I to the 26th times I to the 1st. Maybe you need to see that, right? And then you can say I to the 26th. Well, 26 divided by 2 is 13, so therefore I can say I squared to the 13th power, right? Times I. Now we're about to get the answer, right? So I'm going to simplify this fully because I know I squared is -1. So negative 1 to the 13th power times I. All right, well, when a negative is to a odd power, it becomes, times an odd amount of itself, right? Negative 1 to the 13th power is still just negative 1, is what I'm saying. If it was to an even power, it would be positive 1, but since it's to an odd power, it's going to be negative 1 times I, right? Which is just going to give you negative I. So that's the overall answer. Let's do another one. Let's do another one like that so you can see where I'm coming from again. So let's go with some ridiculous, I to the 253rd, I don't know. Just any number you want. So first thing I need to do is make it even. And I'm always going to make it even by one number, by subtracting, one, kind of looking at it as a subtract. So this would be I to the 252nd times I to the first. Breaking it down, just subtracting 1 from it, Now I'm looking at 252, and I divide that. 252 divided by 2, right? So that's 252 divided by 2 would be 127. Let me make sure before I get up here and work it all out. 252 divided by 2, 126. Yeah, that's on me. So this is I squared, right? That's just I squared to the 126th power times I. Well, I squared is negative 1, and to the 126th power, all right, times I. Well, negative 1 to the 1 to an even power is going to be positive 1. So this is 1 times I, which is I. Easy as that, right? Go the easy way. There's other ways to do it. This is the easy way to do it. All right, so let's go to the negative. So I to the negative 112th power. Let's go there. I to the negative 112 power. All right, so first, couple things you need to know about exponents, right? So first, if I have a to the negative b power, then that's equal to 1 over a to the b power, right? That's a property of exponents. And kind of the same in the same thought process, if you have 1 over, I'll just switch it up and say x to the negative, 5 power, then that's equal to, you can bring it to the numerator and say that's x to the 5th power. All right, I'll give you one more and I'll mix them together. So let's say I have x to the positive 5th power divided by a to the negative b power, right? Everybody just thinks like, oh, you flip it. Well, you don't necessarily flip it. If it has a negative power, you push it to whatever, if it's in the numerator. Let me add something here too. This is a 5, or I'll put a different number. I don't want you to. So keep that A. Let me say 7. I'm just making this part up, right? These are 3 separate little examples. Now, every term has a power. I should say every number has a power, right? Or letter has a power. 7 has a 1 here. You don't see it because it's just understood to be there. But that's a positive exponent. I don't need to move it. But the A, however, has a negative B. I need to move that A, right? So I move it to wherever it's, if it's in the numerator, I move it to the denominator. In this case, it's in the denominator, so I move it to the numerator. So it becomes a to the positive b times x to the positive 5 divided by 7 to the positive 1. Right? That's considered proper mathematics. In math, you can't have a negative exponent in your answer and it be considered fully simplified, right? All right, so I'm erasing this stuff. That was just me showing you these properties of negative exponents, what you can do with negative exponents. right? So this would equal 1 over I to the 112th power. All right? But let's just focus on this part right here, right? So we know it's going to be in the negative. Let's focus on that, right? Oh, man, I'm trying to change my color. Blue. All right, so I to the 112th it's already an even number, so I don't need to add or subtract anything to it. Now I can just say this is I squared 112. Let me redeem myself and say 56, right? 56. Yes. All right. Confidence in that one. So this is negative 1 to the 56th power, which is positive 1. So this becomes, this 1 that was up here, 1 divided by, and then what I just did is 1, and 1 divided by 1 is indeed 1. So that's your answer. All right. On a test, if I give you this, so many people just give me these magic answers and they don't have any reasoning or thought behind it. I want your reasoning. I want your thought, right? If you're not providing that reasoning and that thought process, you're just saying, oh, I see a pattern. It's either I, it's negative I, it's 1, it's negative 1, and you just write one of those and say, I got a 25% chance of being correct. You got a 100% chance of being incorrect if you don't have no work. So show that work. That's what we're here for, putting the work in.